The general mechanism of polyester involves the reaction between the acid and the alcohol, and there is the nucleophilic addition between alcohol and acid to produce polyester. This is the basic general reaction of polyester. So why here is OH or OR and Cl or OCOOR. I'm going to show you how the reaction in polyester happen. So, basically, okay, saya nak buang ni. Okay, basically, if you have a structure of R, C, Y, okay, with the acid functionality, react with the alcohol, HOR here. So, in production of polyester, this one will be formed as a byproduct. So, the result or the polyester will be RCO here and OR. Okay, ini R plus with the HY. Okay, this is the basic polyester structure. Now let's look at if we have the reaction HO, C, H2, CH2, OH plus with, this is the ethylene glycol, react with terephthalic acid to produce polyethylene terephthalate. So we have a COOH. Oh, sorry. It's quite difficult for me to use this drawing pad. Okay. HOOC, and we have the ring structure here, and COOH. Okay, so the reaction is between the ethylene glycol, which contain 2 OH functional group, and terephthalic acid with have 2 carboxylic acid at the end of the bond. So it will result in. So you need to figure out what is the byproduct yield or byproduct produced. So it is the H2O formation as a byproduct, and just copy down the above structure. So H, make a bracket here, O, CH2, CH2, and mix with this structure. Okay, O, so we have C double bond O. Okay, it is okay if you want to write it like this, and with the ring structure here, and continue with C O O H. So close the bracket here with the N plus the water. Okay, so actually the water here it has 2n minus 1 bracket. It is okay if you miss to write the 2n minus 1. So this one is the example of polyester reaction. So you might want to try with other polymer, for example the polyamide and also polyurethane or the polycarbonate. Okay, please try at your home. Try by yourself and good luck. Okay, polycarbonate. Oh, it is the industrially most important, which is produced from the reaction of bisphenol A and phosgene, or from diphenyl carbonate. The reaction of bisphenol A and phosgene is carried out as an interfacial condensation. In this case, the phosgene is in the organic methylene chloride phase and the bisphenol A is present as the disodium salt in an aqueous alkaline solution, and the reaction occurs at the phase boundary. So look at the structure of bisphenol A. It has two cyclic rings, and at the end of the structure, it has a two OH functional group. And the chemical structure of phosgene contains Cl, Cl, and CO. And the structure for polycarbonate, H here and O. Copy the structure here, O, and remove the H here, must be outside. HCl. Okay, so dia akan ambil yang ni lah, HCl yang ini. Okay, and C double bond OO and Cl. Alright. Polyamide. Okay, polyamide or nylon are characterized by the presence of amide linkage, which has a CO and H on the polymer main chain, and the polymerization become diffusion control very quickly, so a number of polymer chain grow at the interface. And the nylon rope trick do not need stoichiometric equivalence, and this method can also be used for the production of polyester and polycarbonate. The amidation of amino acid, it produces the amide bond with amine structure and the carboxylic acid structure and water as a yield. Amidation of triamine and diacid involve the use of the two functionality of amine NH2 and two functionality of acid, call it as a diacid. And amidation of triamine and diacid chloride involve the two amine structure and diacid together with chloride functional group. And this one is the latent polymerization, also attached at the end of the structure here is NH, amine structure. So make sure you practice how to draw a nylon, how to produce a nylon 66 and nylon 610. Polyamide are semi-crystalline polymer. The hydrogen bonds between the amide group of adjacent molecules are the reason for the elevated Tg compared to other non-polar polymer. And the properties of the various types of polyamide are essentially determined by the hydrogen bond between the amide bonds of neighboring macromolecule. For example, polyamide 6, it has melting point of 222 degrees C, and polyamide 66, it have slightly higher melting point, which is 260 degrees C. Okay, this one is the example of nylon 66 chemical reaction. So we can see that adipic acid and hexamethylene diamine, when heated, it will produce byproduct here. This one is the structure of nylon 66, and it is the you might have familiar with this structure, so make sure you practice how to draw the chemical structure. Okay, in your test, I might want to ask the question or the equation you need to draw, and yeah, as you can refer to the books, so it is easier for you. But try to write it on the paper so that you can familiarize with the functional group and the structure. Polymer of isocyanate. Okay, the reaction of trifunctional isocyanate with di or trifunctional alcohol, amine, or carboxylic acid form insoluble polymer or crosslink. The reaction often occurs at room temperature and without the formation of byproduct. By adjusting the stoichiometry, the molar mass can be controlled. The use of monomer with more than two functional groups leads to the formation of crosslink point. So actually this is referred to production of polyurethane. Okay, polyurethane produced by stepwise polymerization, but it not produced by product or water. Okay, so the reaction here in the figure is show the reaction of isocyanate with the alcohol, amine, and the carboxylic acid to produce urethane, dialkylurea, and also amide. Commonly used diisocyanate, TDI-2,4-toluene-diisocyanate, NDI, MDI, and HDI. So this is the structure for namely isocyanate functionality. Reaction of an isocyanate with an alcohol is technique to produce polyurethane. So in polyurethane we have hexamethylene diisocyanate to be reacted with ethylene glycol to produce an urethane linkage. So it doesn't produce byproduct, but it exhibits condensation polymerization or step growth polymerization, which is chain growth polymerization. So in this type of reaction, usually active hydrogen is transferred from one molecule to the molecule. So basically, it is the step growth polymerization, but it follow the chain growth polymerization, means that it is produced by step growth, but follow the mechanism in chain growth polymerization. Okay, polyurea, hexamethylene diisocyanate, react with ethylene diamine to produce the urea linkage. Okay, what else? I think you can read by yourself. Okay, what else we have here? Okay, we have a quick exercise. Write the repeating units and byproduct expected from the following polymerization reaction. So please try at home. Try to use the to refer to the notes earlier. Write the repeating units and byproduct expected from the following polymerization reaction. And I assume as this is your exercise at home. Okay. 7. Okay, write the monomer for the following polymers. Okay, so you have 10 exercise to be done, and please share at WhatsApp group your answer for this. Okay, because in your test, I might want to ask this type of question. Okay, that's all we covered for chapter 2. Thank you. If there is any question, please ask.